Hey, Sean Walia here, Sean Walia Math. Today we're going to be talking about factoring simple trinomials. Let's do this. Okay, so we're factoring simple trinomials. These trinomials are of the form ax squared plus bx plus c. And we're going to let a equal numero uno for all of the examples in this video, okay? We'll let a equal something else in the next video. We'll call that factoring trinomials part 2, okay? So for part 1, we're just going to be looking at examples like something like x squared plus 4x and minus 12. Now, before we go any further, this is assuming, of course, that you have already learned common factoring. If you haven't, please check out my video on common factoring and before you do this one, okay? Okay, let's do it. Okay, so here you go. You got a trinomial you need to factor. And the first step is to take the constant at the end, and you're going to write out all the factor pairs of 12. Now, you can't miss any, and you want to make sure you get them all. So start with 1 always. So we'll go 1 times 12, very obvious. You always start times 1 times whatever is there. 2 times 6, 3 times 4. And that's it. Once you've written out all of the factors of 12, you now have to ask the question, what do these factors need to do? Okay, now it's actually being, the information is there. If you look in the trinomial, if you look right there, you see the subtraction symbol. That's telling you what the factors need to do, okay? So they need to subtract to create, okay, to create 4. Okay, positive 4. All right. So that looked pretty terrible, but get over it, okay? Like, you look at the factor pairs, you know, you got them all in front of you. Which one of the pairs subtract to make 4? 12 minus 1, 6 minus 2, or 3 minus 4? It should be obvious. It's 6 and 2. Once you've decided on your factor pair, you can open up some brackets like so. You can put x here in front, and you can throw in the factors that you chose. So the first step is just figuring out which factors are going to subtract to make 4. But now we have to make positive 4. Well, how are we going to do that? Keep in mind that this 12 here, that comes from multiplying 6 times 2 if we were to FOIL this out. Now, in order to make a negative, your choices are plus, minus, or minus plus. It's very, very important to make that recognition because you don't want to be choosing between 4 possibilities. You don't want to be like, well, at this point, I could have plus plus, minus minus, plus minus, or minus plus. That's too many options. Understanding the FOIL process, you should know this times this, okay? That's got to be negative 12. So it only limits our possibilities to plus and minus, or minus and plus. Well, which one is it? Is minus 6 plus 2 equal to positive 4? No, it isn't. It's plus 6 minus 2, which is equal to positive 4. So we need the plus with the 6, and we need the minus with the 2. And there's your answer. Now, that was pretty tedious and it took a while, but it's going to speed up, of course, as you get the hang of it, okay? But what I really wanted you to get from this example is very easy, choosing all the factors. How do you choose? You need to look at this sign. What do these factors need to do? They need to subtract to make 4, okay? Now, again, with factoring, it's hard to make a mistake because if you FOIL this out, if I go and FOIL, and I have another video on that process as well, x times x is x squared. minus 2x plus 6x, and then minus 12. Gathering the like terms in the middle, we get, of course, x squared plus 4x minus 12. Check, I did it correctly, right? Of course, when you get really proficient at this, you should be able to do this all in your head. Okay, you should be able to check it in your head. And hopefully you get to that level, because when you get to calculus, this, of course, is a much smaller part of a much bigger problem, okay? Okay, let's take a look at another one. Let's say we have x squared minus 4x minus 24. Okay, so we're going to write out the same process as before. We're going to write out the factors of 24. We've got 1 times 24. We've got 2 times 12. We've got 3 times 8. 4 times 6. And I think that's it. Yeah, that's it. Okay, so I want to trinomial factor this. Okay, so what do these factor pairs need to do? This is a really important step, so make sure you follow what I say here. They need to subtract to make -4. 24 minus 1, 12 minus 2, 8 minus 3, 6 minus 4. Do any of those subtract to make 4? The answer is no, none of them do. What does that tell you? Basically, it tells you that this cannot be factored. And, I believe that knowing when it's appropriate to factor is equally as important as knowing when it's not appropriate to factor. And this is a case of that. When is it that I can't factor a trinomial in this form? Well, when you write out the factor pairs and you cannot find a factor pair that will, in this case, subtract to make 4. Okay? Okay, cool. Let's take a look at number 3 here. Okay, so we have x squared minus x minus 6. Okay, same process as before. We're going to write out the factors of 6. We got 1 times 6. We got 2 times 3. Okay, we've exhausted all the possibilities. What do these numbers need to do? They need to subtract to make, what's the coefficient of x right there? It's -1. Okay, so which one of these subtract to make 1? 6 and 1 or 2 and 3? Obviously 2 and 3. We open up our brackets. We throw in the variable, we throw in the numbers, we don't consider the sign yet, not until everything's in there. Now I can be like, okay, well, how are we going to do this? How am I going to create -1 with 2 and 3? Now, again, you should know that there are only 2 possibilities for signage here. It's either plus minus or it's minus plus. Which one is it? Well, we need to create -1. -3 plus 2, that gives us our -1, right? -3 plus 2 is equal to -1. And if you FOIL this out, you will see you're back to x squared minus x minus 6. Okay, great. Let's take a look at another example. Now, this example, it really kind of lends itself to the previous example. Look at this example. We got x squared minus x minus 6. Okay, and here we saw that the numbers needed to subtract to make -1. All right, well, if you're following what I've been doing so far, when we look at example 4, you should know what these factors need to be able to do. And this often, this case often confuses students because they're not as confident with integers as they should be, okay? So same thing, we're gonna write out the factors of 6. I got 1 times 6 and 2 times 3. Do you know what these factors need to do? They need to add to make -5. Now, you may be thinking, how can something add to make -5? Well, I'll show you, okay? Which ones add to 5? 2 and 3, okay? So definitely. So we open up our brackets, x, and we throw in 2 and 3. Now, at this point, again, you should know where, if I multiply this out, where does that 6 come from? It comes from this being multiplied by this. And your choices at this point are either plus plus or minus minus. And again, you know, being cognizant of that, knowing what your choices are at this step is key, all right? Because you don't want 4 choices, you only want 2, just so that it's a little bit easier on yourself, okay? So which one is it? Is it plus plus or is it minus minus? I'll tell you, it's minus minus. Why? Well, what is minus 2 minus 3? I'll tell you, it's -5. It's the value we're trying to create right here. We've done it correctly, okay? Let's speed this up a little bit more and get some more examples done here for you, okay? Okay, so example 5. Example 5, we've got n squared. You'll notice I changed the variable, no big deal. The variable is now n as opposed to x. All right, here we go. Now, you know, sooner or later, you're going to recognize which examples are more difficult than others. This one, I would say, is a fairly easy one because there aren't very many factors of 9. You have 2 to choose from. What do these factors need to do? They need to add to make -10. Okay, which ones add to make -10? 1 and 9. So I'll throw in my n's. I'll throw in my 1 and 9. Again, because it's positive, my choices are plus plus, minus minus, and hopefully you know it's minus minus because -1 minus 9 is -10. Okay, number 6. Number 6, let's take m squared minus 3m minus 40. Okay, so again, starting with the factors of 40, I got 1 times 40, I've got 2 times 20, I've got 4 times 10, no, 5 times 8, and I've got 4 times 10. Okay, you know, you may not be very good with your multiplication tables. You may have to grab your calculator. You may have to grab it and be like 40 divided by 2, divided by 3, divided by 4 to figure out the factors of 40, okay? And there's nothing wrong with that. You know, you may need to do that in order to get the question done. Okay, what do these factors have to do? They need to make, I'm hoping you're filling in the blanks there. They need to subtract to make -3. Which factors do this? 8 and 5. Okay, so we open up our brackets. We throw in m, 8 and 5. Now, this is minus. What are your choices right now? You should know plus, minus, or minus, plus. How are you going to make -3? -8 plus 5. Boom, there you go, okay? Moving right along here. Hold on, what number was that? That was 6. Okay, number 7. Now, number 7, I just kind of, I just changed something a little bit. You'll notice that the first term is a to the 4th rather than a squared. It doesn't really change a lot. Same process, factors of 18, 1 times 18, 2 times 9, 3 times 6, okay? What do these numbers need to do? They need to add to -11, all right? Which ones do that for us? 2 and 9. Okay, the difference though, a to the 4th, I'm gonna put a squared here and a squared here. The numbers that add to make 11 were 2 and 9. We have to make -11, so -2 and -9. Now, this one isn't done, unfortunately. This is a difference of squares right here. I have another video on difference of squares factoring. So if you haven't seen that, perhaps you should check it out. And then you'll be understanding what I'm doing here with the difference of squares. Okay. Okay, cool. 8. Now, here's another little twist. Okay, what happens if there is a common factor? Now, I mentioned this in my common factoring video, and I can't stress this enough. If you don't common factor first, it's going to be wrong, okay? It's always the first type of factoring you try. If you don't do that, it's not going to work for you, okay? So in this example, hopefully you can see all of these 3 terms are divisible by 2, okay? So I'm going to pull the 2 out, k squared plus 11k plus 30. And now I have the trinomial in there, and I'm going to factor that trinomial inside, okay? So, we'll just keep the 2 there. I know this is where I'm headed, so I'm just going to go like that. Factors of 30, 1 times 30, 2 times 15, 3 times 10. I forgot one, didn't I? 5 times 6. Okay, boom. Okay, what do these numbers need to do? They need to add to make positive 11. Right? You really got to understand that step. It is so key, okay? So they need to add to make positive 11. So which ones do it? 5 and 6. How do you make plus 11 with 5 and 6? You go plus 5 plus 6. And there you go. Done like dinner, okay? Moving right along. Again, always forget what number I'm on. Number 8, number 9. Number 9, I'm just going to do another example like the one I just did. Okay, so perhaps 5v squared minus 30v plus 40. Okay, again, and so many of my students, they think, oh, trinomial factoring, but did you common factor first, right? Make sure you recognize, hey, I can take a 5 out, v squared. If there's a number in front and you can't pull it out, that's the next lesson, okay? That's factoring trinomials where the leading coefficient is something other than 1. Okay, so hopefully you're good up to here. All right, so moving right ahead, I know I have a trinomial here. As you've seen before, not every trinomial factors, but I have a good feeling about this one. 1 times 8, 2 times 4. What do these numbers need to do? They need to add to make negative 6. To me, it's obviously 2 and 4, and they are both negative. And there you go. Bushaka. All right, so you know what? I think we'll finish with the 10th example. And I believe what I'll do there as well is I'll take it to another page. I'll just give you kind of a difficult example, something that you may or may not see. And what's happening in this example is that you don't have a variable, you have an expression. It's hard to see, but it becomes revealed if I say, hey, let a equal x minus 3. Okay, let a equal x minus 3. Okay, so wherever there's an x minus 3, I'm going to put an a. Okay, so I've got a squared now minus 2a minus 15. It doesn't look so bad now, does it? Okay, we can't just forget about this, though, okay? We're going to factor it first, though. Got 1 times 15. I got 3 times 5. Which numbers subtract to make 2? Definitely 5 and 3. Okay, so here I go. A, 5, and 3. And then I'll put negative, positive, negative 5a plus 3, that's the negative 3a. But wait, a is not a. A is actually x minus 3. So now what I'll do is I'll put that x minus 3 back where a is. So I have x minus 3 minus 5. And I have x minus 3 plus 3. If you simplify this, you're going to have x minus 8 and x. And there it is. There's your factored expression. One more, okay? One more, just one that's backwards, okay? Like something like 8 minus 2x minus x squared. So I wanted to show you one that was backwards just in case it shows up for you and what you should do. It's exactly the same. You're going to grab here, you're going to go 1 times 8. You're going to go 4 times 2. Which numbers subtract? Oh, excuse me. Which numbers subtract to make 2, okay? So I'm going to go like this. I don't know, maybe I chose a bad example here. Here we go. I'm going to go x here and x here. And then 4 and 2. And then what? Okay, this is where it gets a little bit weird, okay? Because I've got to make negative 2x, and you'll notice that the signs aren't here anymore, right? Okay, well, you need to know that this middle term here, this term, its creation, it happens with the combination of this one and this one. So this term, when you multiply that, that'll be 2x. When this term multiplies out, that'll be 4x. And so how am I going to make negative 2x? Well, this would have to be negative, and this would have to be positive. Therefore, I'm going to put a negative here to get that negative 4x, and a positive here, and there it is. Okay, so I thought I'd just throw that example because sometimes I see those in students' homework, and it can be a little confusing when you have to go backwards. And hopefully you learn to run before you walk, and you can do the previous examples. Thank you so much for watching, and if you like the video, definitely hit like, and if you could subscribe, you would be my first subscriber because I don't have any yet, and that's pretty exciting for me. Really excited to help people out with mathematics and make more videos. So please do encourage me by liking my video and subscribing. I'd really appreciate that, okay? Take care, and I'll see you in my next video.